Welcome. So today we're going to be discussing molarity and dilution. And by the end of this lesson, you guys should understand how to calculate the concentration of a solution. So first off, let's discuss what molarity is, right? What is molarity? It is a measurement of concentration. We could talk about the word concentration for a moment. That basically means it's a measurement of how much stuff is dissolved in your solution. When it's more concentrated, you have more stuff dissolved. When it's less concentrated, you have less stuff dissolved in there and more of the solvent. So a higher molarity is going to mean that more solute is dissolved in the solution and it is more concentrated. Molarity is represented with a capital letter M. And so that's going to be the symbol for molarity. It's also like the unit. So you know how we represent volume in liters and we represent mass in grams. We're going to represent concentration using molarity. So we have an equation. So molarity is calculated by taking the moles of solute and dividing it by the total volume of solution. And we know that we measure volume typically in liters. So basically, it's going to be moles divided by liters is going to give us our molarity. Now, we can actually use a triangle to help us with this. Since this is sort of a 3-variable equation, we can use this triangle to help us with it. I would put moles on the top. I would put molarity and liters representing volume down on the bottom. So the way that this works with the triangle, in case you've never done algebra with a triangle, instead of just straight algebra, basically you're given 2 of these values and you have to figure out the third. So whichever one you're trying to calculate, you cover it up. Like if I wanted to figure out moles, I would cover up moles, and that would leave molarity and volume here. And since they're next to each other, I would just multiply those 2 and it would give me my moles. Or let's say that I was trying to figure out liters. Well, then I'd cover up liters, and what that does is it leaves me with moles over molarity. And so to figure out liters, I would take the moles I was given and divide it by the molarity I was given, and that would give me liters. So in case you're not familiar with the process of doing algebra with a triangle instead of just doing algebra, that's how you would use this. If you're comfortable just doing algebra and rearranging things algebraically to solve for an unknown, just use the equation. Okay, so first off, you'll notice that the amounts of solute here are going to be in moles. So solute must be converted to moles. If you're given an amount of solute in another unit, let's say grams, because typically we would measure the amount of something in grams, you're going to have to convert that to moles using molar mass. Volume of solution must be converted to liters. Now, often in the lab, we do small scale experiments where we're measuring things in milliliters. And so I'm going to put this conversion factor out to the side in case you need to convert. 1,000 milliliters is equal to 1 liter. So you could use that conversion factor there to convert your milliliters to liters. But those are the units that must be in this calculation, okay? You have to have moles, you have to have liters. You can't do grams and milliliters. It's not going to work out. You're not going to get the right number. So make sure that if you're given an amount of solute in grams, you convert it to moles. And if you're given an amount of solution in milliliters, that you convert that to liters using this conversion factor here. So here's an example problem. Determine the molarity of a solution. So we are looking for M containing 30 grams of sodium hydroxide in 900 milliliters of solution. So again, typically small scale experiments, our volume is here in liters or milliliters, and we measure the amount of solute in grams because we can use a scale to measure that. We really can't measure moles. So a couple of things we got to do. First off, I'm looking for molarity. So if I, cover that up in my triangle, right, for this problem, that's what I'm solving for. Then what I have is moles over liters left. So I'm going to have to take moles and divide it by liters to solve this problem. The issue is I don't have moles or liters at this time. So let's fix that. I'm going to take my 30 grams of solute, and that's the stuff I'm dropping in the water, correct? The solute is what you're putting in the solution. The solvent is sort of the liquid part that's dissolving it. The solvent scientifically is defined as the one that's in greater proportion. So whichever one you have more of, that's going to be your solvent. And then the solute is the thing that is dissolving or dissipating within that solution. Anyway, we're dropping sodium hydroxide in our solution here, so that's our solute. And so I'm going to take 30 grams of NaOH and convert it to moles. Now, if I have grams of sodium hydroxide up there, then I need grams of sodium hydroxide here, and that's going to come off of the periodic table. So you can't see me, playing around with my calculator over here, but I'm going to add together 22.99 because that's the mass of sodium. I'm going to add 15.999 because that's the mass of oxygen, and then I'm going to add 1.008 because that's the mass of hydrogen. And so what we get as a total mass of sodium hydroxide is 39.997 grams. That's equal to 1 mole of sodium hydroxide. So if I look at the way that this is set up, I'm going to take 30 and divide it by that molar mass. And what I end up with is about 3/4 of a mole, 0.750 moles of sodium hydroxide. So that's how many moles I have. Now the other issue was the milliliters. We can't do this calculation with milliliters. It has to be liters. So I'm going to take my 900 milliliters and use that conversion factor from up here, right, this one, and I'm going to convert it to liters. So what I know about milliliters goes on the bottom. It takes 1,000 milliliters to equal 1 liter. So if I divide there, that is going to be a value of 0.900 liters. Okay, so top divided by bottom gives me 0.900. Now another way to do this, an easier way to do the milliliter to liter calculation, because we do it so often when we're doing these calculations, is anytime you're dividing by 1,000, basically you're just moving that decimal. So if my decimal was here, I'm going to move it 10, 100, 1,000. I'm going to move it 3 places to the left. And so that gives me 0.900 liters. So if you need to go from milliliters to liters, you could just move the decimal 3 spots to the left, because that's going to be 3 units of place value. Oh, okay, well, we have to actually solve the problem, right? I was ready to move on, but we have to actually solve the problem. So again, we're trying to figure out molarity. And we said up here that molarity is equal to my moles of solute divided by volume of solution. If I cross out molarity, I've got moles over liters. So that's exactly what I'm going to need to do. I'm going to take moles, which was 0.750, and divide it by my liters, which was 0.900. And I end up with a molarity is equal to 0.833. And again, the unit is molarity. So this right here, that's my answer. Okay, capital M for molarity, because that's the unit. Okay, so then let's talk about the next part of this. Let's discuss dilution, okay? So most of you have heard the word dilution before. Basically, it's watering down, right? I mean, you've heard of it before. You kind of know what it is. The scientific way of thinking about it is we are adding solvent in order to decrease the concentration of solution. Think about it proportionally. So let me go back up to the formula for molarity. If I increase the bottom part of this proportion, if I increase the number of liters, overall that's going to bring the value of this proportion down, right? So by increasing the denominator here, I am decreasing the value overall of molarity. And so that's what dilution is. We add liquid, most of the time liquid, most of the time water, right? We water it down, we add water, and that's going to decrease the concentration of the solution. Okay, so we have a special equation just for dilution. And it looks kind of like equations for gas laws. So we're going to take our initial molarity of our solution and the initial volume of the solution, and we're going to set it equal to our final molarity of the solution after dilution multiplied by the final volume. So this is the equation, right? Initial molarity times initial volume is equal to my final molarity times my final volume. So it looks a lot like a gas law. So it says calculate the concentration of the solution from the previous example if it is diluted to a volume of 2 liters. Okay, great. So we need to calculate the concentration. So we're figuring it out after it's been diluted. So we're trying to figure out the molarity after it's been diluted, because remember, concentration is molarity. This is our new volume. So this is the final volume. Let me go up to the previous example, right? In my previous example, my initial volume was 0.900 liters, right? So that's my initial volume. That's how much of it I have right now. And the initial molarity is 0.833. So let me plug all that into the equation and solve, right? So my initial molarity was 0.833 molar, and that's how we say it. So when we're using it like a unit, when I'm saying, you know, the value of molarity is 0.833, then that unit that's attached to it is molar. So not 0.833 molarity, but 0.833 molar. That's just how you say it. Anyway, the volume of that solution was 0.900 liters. Now, just like in the gas laws, it's important that your initial volume and your final volume are the same unit. So they both have to be liters, or they both have to be milliliters. It doesn't really matter, but they both have to be the same unit. In this case, volume 2 was given to us in liters, so I used the value for the volume of my initial solution in liters. That way it's the same unit. Okay, now we don't know what M2 is, so that's like my X right there. That's my unknown. And then I know that the final volume is going to end up being 2 liters. Okay, so then we just use order of operations, and I'm going to multiply either side of this equation. So 0.833 times 0.9 gives me 0.7497. Now remember, I'm not rounding anything until I get to the end. And then 2 times x is going to give me 2x. So then to solve for x, I need to divide both sides by 2. That way this guy cancels out. And whatever I do to one side, I have to do to the other. So 0.7497 divided by 2 is going to give me 0.37485, but we're at the end of our calculation. Oh, and if I look at this one was only 2 significant figures, so I'm only going to keep 2 significant figures in my answer. And so this x value represents my final molarity, and that is going to be a value of 0.37 molar solution. So that's going to be my final answer. Now let me think about this. Does this make sense? The way that this is set up, it's going to be inversely proportional. Okay, so let me write this over here. Or indirectly proportional, right? So what that means is if the molarity goes up, then the volume goes down, or vice versa. If the molarity goes down, then the volume goes up. And if we think about what we had here, our initial volume was 0.900, but then it went up to 2. So if my volume went up, then my molarity should have gone down, right? If my volume goes up, then my molarity should be going in the opposite direction. And it did. It went from 0.833 down to 0.37. So it's less concentrated, which makes sense because we added a bunch of water to this solution. So that's going to decrease the concentration of it. So I hope this helps explain the process of calculating molarity and dilution.